Hello, everyone! Welcome to the first KieLive of 2021. Hey, Porcelli, excited for today's talk?
Yeah, so I'm excited that it's a new year. Whole expectation of this year. A lot of changes in the world is expected this year. And to start to kick off an amazing year, I hope that we have today one of the big names in our group.
Yeah, so today we have a guy who's been working with Drools, the key rules engine, for almost 10 years now. Like he's completing 10 years this year. So he knows basically everything about rules, and he's today the project lead, and he's here today to tell us all about the engine, all about the algorithms, and he will wrap up with nice tips for us on how to best implement our rules to take advantage of all the things that we will learn about the internal stuff of Drools today. So I'm looking really forward to learning everything directly from Mario, straight from Italy.
Yay, Mario. Oh, bring him.
Hi guys.
Hey Mario,
for having
welcome.
me.
Thank you for accepting our invite for being here today.
Yeah, thank you for having me.
But Karina, you said a lot of great things about Mario. He's our lead, Drools lead, has been working this for 10 years. But before we jump in, I want to learn more, Mario, about this end of the year that you went viral. So
Mario went super viral on the network, and it was not because of software directly. What happened?
This tweet that I have here went viral, and Mario was stamped in all newspapers all the globe. And I want to learn from that, direct from the source. How it happened, Mario?
Probably it's just demonstration that stupidity can go viral. If you read the tweet, it was really a stupid thing. So yeah, I think there is this conspiration thing that I think it's all around the globe now, but in Italy it assumed a special form in this diagram, meaning that I think this is something that actually started in Romania, but probably a few knows that Romanian and Italian are quite similar languages, so somebody translated the original post in Italian, and then this thing started circulating on private chats like Telegram or WhatsApp, and I received.
So theoretically, this is the 5G chip inserted within the COVID vaccine, right? And then you saw it.
Yeah, so there is this conspiration around the globe that we are going to have this 5G chip implanted through the vaccine. And in Italy, it assumed we also had the diagram of the 5G chip. And a friend of mine sent it through me via WhatsApp. And he was quite worried, actually, seriously, because he was going to have the vaccine the week after. So I figured out what it was. It's actually the electric circuit of a guitar pedal. And yeah, I called him. I calmed him down, and yeah, we had a laugh together. My friend had his first dose of the vaccine last Wednesday, and yeah, and everything is fine. No 5G chip in his body so far. So yeah.
Thank you for unraveling that myth for us.
Okay. That's awesome, right? Because it's there is a chip, it's a guitar pedal chip. What this is awesome.
Yeah. It's really a stupid thing, but in reality, all the 99% at least of this conspiracy theory are very stupid, easy to debunk. So yeah, it's
Yeah, okay, okay. I'm really glad that you did it because I wouldn't
Okay.
be able to identify this as a guitar pedal. So thank you for that.
Well, in
Good.
reality, they didn't bother translating a few things. If you see the diagram, you can read bass or foot switch. It's quite weird to have a foot switch. But in reality, not many Italians speaks English, so foot switch doesn't mean anything to them, and they didn't pay attention to the label on the diagram. Actually, they just replaced one single label with something like 5G transmitter, and that was all. So yeah, they were done.
Indeed, very
Yeah.
nice. Thanks for the curiosity, Porcelli,
Yeah.
about our popular invited guest today. So, Mario, let's get started with our
Okay.
session. What do you
Okay.
think? You ready for it?
Yeah, I think I am. Yes.
So, everyone who's watching us now, feel free to interrupt us with questions. As usual, we will interrupt the speaker if he wants us to, and he already allowed us. So, we will interrupt him. So, feel free to share your questions in the chat. We'll be looking and we will be on the backstage. Okay, Mario? Good
Okay,
presentation.
great, thanks. So yes, as Karina anticipated, I'm the Drools lead of the project lead of Drools, sorry, which is the rule engine of Rete. And what we will cover today is mostly two things. I want to share a bit in a bit more detail than usual the internals of Drools, the internals of generic rule engine first and Drools specifically after. And then in the second part, I wanted to give some practical hint to write readable, maintainable, and well-performing rules. Okay, so let's get started. Very quick introduction. By the way, I'm assuming that you know what Drools is, you know what a rules is, even if I have this very quick introduction, but please feel free to interrupt me if you have any question. So what is a rule? A rule basically is made of, it's a piece of code that basically is made of two parts. Left-hand side part where there is a series of pattern matching statements where you define the characteristic, the feature of the object that you want to retrieve from the working memory. And then when Drools retrieve one or more objects that satisfy all these conditions, it triggers what is called the right-hand side, the consequence of the rule. So it finds a match for the precondition, let's say, and then in the right-hand side, you have the consequence, meaning that the rule is fired with the object found in the left-hand side. So just to give you an idea, what's the difference, for instance, between a plain Java method and a rule? With a plain Java method, you have you directly call a method and you pass the parameter to that method. Okay. Conversely, in declarative programming, in a rule engine in general, you cannot invoke a rule, and you cannot pass argument to the rule. The argument are found from a set of objects that have been inserted inside the rule execution session. And then when the rule engine find that set of object, or one single object, as in this case, it triggers the consequence that, again, you can see the right hand side, the consequence, like the body of the method in my first example. But it is not like this, because it is not a method. Again, you are not invoking it, you are not passing parameter to it. So this is the main difference. So what happens in reality, specifically inside Drools, but this is a very high level overview, so it's basically valid for all rule engines. So you basically feed the rule engine with two things. The first thing is the rule base, is the set of rules. Okay, so I showed you a couple of very simple examples of rules in the former slide, but normally your rule base is made of hundreds of thousands or even millions of rules. And this is your rule base. And then you also feed the engine with the fact on which the engine itself is going to reason, is going to match the rule in the rule base. So this task, which is the main task of the rule engine, is really the core engine of the rule engine, is done in this pattern matcher, meaning that the pattern matching has the duty of for each rule of finding a set of fact in the working memory that satisfies the condition of the rule. So for each of these match that it founds, it creates an activation. An activation is just a tuple made by the rule itself, plus the set of the facts that activated the tuple that satisfy the precondition of the rule. So you at this point you have a set of activation inside the agenda. Inside the agenda there is a conflict resolution strategy, meaning that there is a even pluggable algorithm to decide which activation should be fired first. So the activation is are ordered using this strategy, and then they are sent one by one to the execution engine, which it's very simple, just invokes the right hand side of the rule. Okay, so this is basically both how the rule engine is made internally and also what it does in practice. Now I wanted to give a bit more in details about the internals of that thing that I called the pattern matcher, which again is the real is the core of the rule engine. So historically, and also Drools followed this, the biggest part of rule engine are implemented following an algorithm that has been invented in the early 80s. It's called the Rete algorithm. Rete is the Latin and also, by the way, of course, the Italian word for network. So when the set of rule bases is compiled inside a rule engine using this algorithm, you end up with this thing that you see in this diagram that is called the Rete network. Actually, it's quite a word, a weird name for me, again, because in Italian, Rete also means network. So to me, it sounds the network, but it is what it is. Okay. Okay, so in this Rete network, you can see a few different kinds of nodes, and you have to imagine that every time a fact is inserted into the working memory, into a session of the rule engine, each of these facts traverses this set of nodes and create joins between different facts, and then creates when it reaches the very end of the Rete network, it creates those activation that then are passed to the agenda. Okay, so you can see a few different kinds of nodes. So there is an entry point node, which is the node that just accept in input the fact. Okay. Then we have a first layer that is made by a set of nodes that we call object type nodes, meaning that these nodes are used to discriminate on the type of the inserted object. So one of these red ball, for instance, this one is to manage the object of type person. So when you insert a person, an object of type person inside the working memory, it will go through this node. Okay, and of course this has to support polymorphism, meaning that if you insert a fact of type child, which is also a person, probably you will have both a node of type person and a node of type child, and in this case the fact will be propagated through both nodes. Okay, so after this first discrimination layer, there is a second layer which is called the alpha network. In the alpha network, we do constraint evaluation of the condition expressed on the single fact itself. Okay, we are not joining fact yet. We are still evaluating one single object. So we are checking if, as in this case, if the name of the inserted person is Mark, or we are checking, for instance, if his age is greater or equals than 18, and so forth. You are evaluating the constraints on that single node. Okay. Then you have another layer which is called the beta network. In the beta network, what happens is that you join multiple fact. Okay. So in this layer, you can have constraint that compare the fields of these two facts. So if I'm inserting two person, I probably have a rule that I want to find a person that is older than the other person. So you can have a constraint like this. In this beta network, we compare different objects. Okay, and this beta network can be quite deep, so you can join multiple facts together, of course. And at the end of the day, well, all the fact matches the constraint, they traverses the whole network, and creating these tuples, this join. And at the end of the day, the tuples, if it satisfy all the constraints, it reaches the last stage that is made by the terminal node. So we have a terminal node for each rule, meaning, so if your tuple reaches the terminal node for that specific rule, it means that the tuple is activating the rule, and the activation, so the pair of the rule itself plus the tuple activating it is added in the agenda, as I explained before. So this is how the Rete algorithm works. Of course, there are lots of optimization inside. There are indexes and stuff like this.
But Mario, I interrupt you briefly, just to connect with the one question that we did for Edson a few lives ago. It's about if it's just a chain of if statements. And here we start to see by the algorithm itself that's not, because you basically decompose the rules in this network, right? And you reuse those things. So it to be more efficient. If you have comparing like the name in different rules, you'll be efficient to be just one place, right?
Okay, yes. So this is something that I missed to mention. It's what we call the node sharing, meaning that if two rule has the same constraint for the same kind of object, for the same class, and this is very, very common, then we don't have a node evaluating that constraint for each and every rule. But we have one single node, and this node is shared among all the rules. So it can do alone the constraint evaluation for all the rules having that same constraint in the left-hand side.
Thank you very much. This graphic is very clarifying that. Thank you for that. So
okay. And yes, this not sharing thing, thank you, Alex, that you mentioned this, because it's also very important in the second part. So this is the original Rete network. Drools had its implementation of this algorithm till Drools 5. Starting with Drools 6, we didn't drop it completely. We just reworked it heavily and ended up with a quite different algorithm that we called Phreak. What's the characteristic of Phreak? So the main difference between Phreak and Rete is that Phreak is a lazy algorithm. Okay, what does it mean? It means that with Rete, when you call insert, when you insert affect an object into the session, into the working memory, at that time it attempts all the propagation. The node the fact is propagated through all the nodes of the Rete network. Okay, Phreak is a lazy algorithm, meaning that this propagation is not performed at insertion time, is performed at firing time. So when you insert affect into Phreak, the fact is the insertion of the fact, or more in general, the action that you took on that fact, which could also be a deletion of the fact or a modification of that fact. The action that you took on that fact is parked in a list. Okay, and then this list is flashed when you call fire, when actually you evaluate the rule. Okay, why we are doing this? Because with Phreak we are able to figure out. We are able to figure out that some part of the network shouldn't be evaluated at all, and we skip that evaluation completely if so. Okay, so let me let me give you a practical example. So this is still a Rete network. Okay, so this node still represents a Rete network to me. So you have a direct cyclic graph from the entry point to the terminal node with all the alpha and beta network inside it. Okay, but the beta network is partitioned into this thing, into this rectangle that we call a segment. Okay, a segment is made so that there is no bifurcation inside the segment. Okay, so this node, these two nodes belongs to the same segment because there is just one single path from F to G to the terminal node of the rule. Here I'm splitting the segment in two because D has two sinks, E and F. Okay, and then the evaluation path of a rule is indeed a path that is made by multiple segments. And as we have node sharing in Rete, we have segment sharing in Phreak, meaning, for instance, this segment having only the node D is shared between the rule R3 and R4. Okay? So why we propagate this object lazily through this network? Because we can selectively detach part of the rule. We can selectively turn on a segment, turn on and off a segment. Okay, so if I know that there is no object, let's say this G is a join between a person and a car. And let's say that I know that there is no car in the working memory. There is no reason to enable this. Okay, so this node is enabled only when a car is inserted, or when a car, probably this is fed by an alpha node that says that the car has to be red. So when a red car is inserted, okay, this G is enabled only when there is an actual alpha input for this join node. And if there isn't, I know that this node is not enabled. I know that this whole segment is not enabled. Why? Because if I don't have any red car in my working memory, it's totally useless to evaluate this whole thing, because there's no way I could create an activation for the ruler 4. Okay, so this means that I could totally detach this part of the rule from the evaluation. I could totally ignore the evaluation of this segment. So I can also skip any work done on the node F. Okay, so this is the real advantage of Phreak. So we propagate eagerly the alpha part, and then the joins are made lazily for this reason. Okay, yeah, okay. So I think I already give you an idea of how the path of a rule is made. So we have a rule is made of more segments, and each segment is made of one or more nodes. Okay, so this trick of detaching and linking part of the Rete network allowed us to have a much more performant engine, because you know, the best optimization, the best way to optimize a task is not doing it at all if possible, and this is what we are doing actually. And we also ended up with a more forgiving engine, meaning that if you have lots of rules, but only a few of them are really activated during a specific session evaluation, you are not paying the cost. In this way, you are not paying the cost the additional rules of the additional rules. Those additional rules, in reality, it's like those additional rules were not there, because they are simply detached by the Rete network with this trick. So we have a faster engine in this way. We have also a reduced memory footprint, of course, because we are creating less tuples, and we have again a more forgiving engine, meaning that if your rule base is bloated of rules that you don't actually need for a specific evaluation, you are not paying the cost of them. And this also enabled yes.
Before you go to the next slide. So we have a question here. So during the evaluation, does the engine treat the effects as independent type? In other words, does it decompose the effects that have nested objects?
No. A fact is a single fact that you insert. And
so what if you have a nested object in there?
So it depends. If the nested object is also has been independently inserted in the working memory with a different insert, you have actually two objects inside the working memory and they are treated independently. If not, then the nested object is just an attribute of the containing object, but it's not by itself a fact. It's not by itself alone a fact that is propagated through the network. The only thing that is propagated are the fact that you explicitly insert into the session.
Okay, thank you, Mario.
Okay. Sorry. So, okay. This is a really internal thing. I will go quickly on this, but the fact is that, as you can see, read in the latest statement of this slide, we are doing some experiment for now to further parallelize the engine. So all this evaluation of constraint at the moment is performed sequentially in Drools. We are doing an effort to parallelize this. Before doing this, we realized that originally our code was starting to be quite a mess because we have a lot of synchronization point and locks around to synchronize the different threads, because of course there are different threads competing and working together on the session, because you normally have your thread when you insert fact and you call the firing, but possibly you can have timers that are or you can have even you can use the event processing that makes automatically expiring events, or you can have concurrently to the use of the session, you can also do what we call an incremental update. You can change the rule base, the set of rules while the session is running without shutting it down. Or more in general, a session is supposed to be thread safe, so you can share the same session safely between multiple threads and insert stuff in it and call firewall rules. Okay, so for all this reason, we had a lot of synchronization point scattered around our code. It was starting becoming very hard to maintain. We did quite a bit refactoring, so this whole synchronization effort is made in one single point, which is in the agenda itself. And now we have this state machine that coordinates the thread and allow each thread to use and make it work only when it's not interfering with other threads. So there is a thread flashing that propagation queue that I mentioned it before when you call the firing. There is a thread for the event. As you probably know, Drools can also run in until out mode, meaning that there is a constant firing going on a separate thread while you insert object on another thread. And this is typically used for event processing scenarios. So why I'm saying this? I know this is something really internal again, but I just wanted to give you an idea. We had lots of synchronization point and logs scattered around the code. Now we have a much better control of these multi-threading issues with this state machine. And this was a precondition to move forward with this thing that is still experimental in Drools 7, but on which I'm still working, which is the idea is that finally leveraging your multi-core processor and have a possibly parallel evaluation of the constraint. How we are doing this? When you enable this experimental feature for now, when you enable it, there is a further partitioning going on the Rete Phreak network. So the Rete network is partitioned in area where you don't have node sharing. Okay, so this is one single area for one single rule, and then these two rules has some node sharing, and then I put all of them in other different partition in other different area, and then I have this third partition, and in this way I'm guaranteed that all these three partitions are independent from each other, and then I can evaluate them in parallel. Okay, at the moment this parallel evaluation is working pretty well. It has some limitation. You cannot use a silence or agenda group. You cannot use a few of the Drools feature. What happens now is that if you enable this flag for a parallel evaluation, but you try to use one or one of these not allowed feature in your rule base, the engine will just figure it out, will emit a warning, and it will switch back to the sequential evaluation. That's all. Okay, so you can give it a try to this option if you want, by just enabling it on a specific key base like this, or with this system property.
Mario, have you noticed significant performance improvements when changing to the multi-thread evaluation?
It really depends on the use case. Of course, yes, you have. You may optionally, you may eventually have a really good improvements, because now, again, the evaluation runs on a number of different threads, typically a number of threads that is equal to the number of core of your CPU instead of one single thread. So eventually, yes, but you have to understand what's going on here. So the whole execution is parallel, meaning that, and this is the reason why you cannot use salience or agenda group or any other thing why
I think Mario froze right in the middle of the explanation. Oh no,
Yeah.
Mario, come back.
Let's see. Well, that's how it works. It's live. So internet connection and all this, what happens. Let's see how
The connection is not put it right.
we got it. Yeah. Let's
Very nice. Let's remove his screen until he gets back. And I'm seeing the parallel discussion that we are having here on the chat. I think this is pretty important to know because we usually, when we work with Java, we do have nested objects. So it's really important to know how to deal with it when we have a rule that uses these nested objects, right?
Yeah, and that's pointed by here. If you know that you're going to be used in a point in time, it's better to add the nested object in the agenda. So we got it back.
Sorry, guys. Yeah, I had a network hiccup. Okay. Any question?
Share the screen again. No, that we are having a parallel discussion on the chat, but we have it addressed properly so far.
Okay, sorry. Okay, so yeah.
Oh, you were talking about the performance on the parallel.
Yes. So everything is done in parallel. So of course the performance are better again, but you don't have everything is really in parallel, including the rule firing. So you can have also multiple concurrent rule firing, which is something that you don't have in the sequential evaluation. This could be good or bad depending on your use case. You need to be aware of this, and this is the reason why you cannot have at the moment you cannot use any of the Drools feature that influences the conflict resolution strategy of the agenda, because you don't have any conflict resolution strategy at all in reality.
Makes sense.
Okay. So this is also something that we added in Drools 7. What we did is that we wanted a plain Java representation of our rule. Okay. Why that? Because first of all, for compile time performance reason, meaning that what did happen before? You can create a jar with a rule set, but in reality, inside the jar, you just have the files in the Drools language, in the DRL files. And then when the jar were loaded again, it has to reparse all the DRL file and do all the checks and create all the basically create the Rete, the Phreak network again from scratch. We wanted to, and this means that to create a rule base from a jar with a significant number of rules, with a few thousand of rules, let's say, it could take a few minutes or even seconds, a few seconds or even minutes, sorry. What we did is that now we have a plain Java representation of the rule. So when you compile your rule base into a jar, what it happens internally, don't worry, you don't have to write this Java code on your own. It is plain Java code, is calling an our DSL, but it's quite complex to be written so far. You don't have to write it by hand, of course. We have a compiler that from DLL, it automatically generates this Java code and put it inside your jar. So when the jar is loaded from your repository, what happens now is that you don't have to reparse the DLL file from scratch, but you just let Java to interpret this DSL, and the product, the net effect of this is that you obtain the rule base again, but in like 2 orders of magnitude faster. Just a few notes about how this DSL is written. We have I tried to make it as type safe as possible. So we are making a huge use of lambda expression, as you can see. But in this DSL, and this is the reason why for now it's not a DSL that it's nice to use for end user, because you don't only have the constraint, the predicate expressed like a lambda expression, like in this case, which is readable enough, but this is a complete model of the rule base, meaning that this DSL has to fully specify the index of each expression, of each constraint, and the property reactivity, if you know something about it. I mean, it has to totally explicitly say what's it's normally inferred from the DRL. So this is the reason why I don't suggest you to write this thing by hand. I suggest you to use our internal, to start from the DRL and use our internal compiler, which is of course available also with our Maven plugin. But what we would like to do in future, so this is one of the reasons why I'm mentioning this, is that we want to allow you to only write the predicate, and then we will have a pre-processing stage that will go through the source code and will generate all the indexing for you. Okay. So yeah, I already discussed all of this stuff. The only thing that I didn't mention is that when the rules were evaluated with the plain DRL, what we did is that we used a lots of reflection, of course. Okay, so to evaluate this constraint, you have a person name that goes through your Phreak network. It reaches the alpha node where this constraint evaluated, and what the alpha node does is reading the name of that person via reflection and comparing it with the string mark. The other advantage of the executable model is now we don't have to use reflection at all, because the way how the constraint is evaluated is by just evaluating this predicate. We are not using constraint at all. Everything it's in the executable model written as lambda expression. This allowed us, of course, on a side to have a faster evaluation also, because you know that the reflection is quite expensive in Java. And the other very nice advantage is that, as you know, probably reflection doesn't work very well with GraalVM. Feel free to ask me about GraalVM if you don't know about it. But one thing that doesn't work with GraalVM, or is not really allowed with GraalVM, is using reflection. So by using the executable model, we can avoid reflection, then we can use GraalVM. This means that we can create a native image of a rule base. and have it booted in a matter of a few milliseconds, really, meaning that this enabled us another quite nice usage pattern, which will be enabled by our project, our cloud-ready version of Drools that is called Cogito. Probably you had a few talk about it in the past. And with this native compilation, you can boot up a fully working rule base in a matter of milliseconds, and this make it also a perfect environment for a perfect fit for a serverless environment. Okay, because if you think about it, in most cases you can think to a rule evaluation like a pure function as a service. It's a rule evaluation as a service. So you may want to put it on a serverless environment, and when you have a complex set of rules to evaluate, you create the rule base. And again, this is very fast if it is compiled natively. You can create the rule base, you throw at it the fact on which you want to evaluate the rules against, and you have the result. And you can see this as a pure function invocation, but backed by a rule engine.
Very nice, Mario. Before we go to the cherry on the cake, so we have two questions. First, on executable models, I think you answered it already. But so we are not only skipping the DRL compilation phase, but also improving the performance since we remove reflection, right?
Yes, correct.
Okay, nice. And the other question is about the, like, can we automatically detect whether a set of rules would benefit from multi-threading? For example, if salience is used, then don't use multi-threading.
Well,
because
again,
if we did it, then we could just like, okay, I know that I can automatically use it if these are not
no, to be clear, if you are using feature like salience or agenda group or any other feature that impact the conflict resolution, you cannot use parallel evaluation. Okay,
Good.
you cannot. So if you enable parallel evaluation and then the rule engine realize that you are using silence in a specific rule, the net effect will be that the engine will emit a warning, say, look, you asked me to run in parallel mode, but I cannot because you are using silence. And it will automatically switch back to the sequential mode.
Oh, so the person won't get an error. It will process, but okay, in a single.
It will emit a warning saying, I cannot evaluate this thing in parallel, and will switch back to the sequential mode.
Okay, good. Thank you. Now let's go to the performance tips.
Okay. This is partially about performance, but mostly about correctness. One thing that I see quite commonly, a mistake that I see made quite commonly by beginners of Drools is something like this. So you have constraint evaluation that also in some way changes the field to be evaluated, or the field the value to field to be evaluated is not a stable value, but it changes without warning the engine. Okay, this totally screw up our indexes. So this really doesn't work in Drools. If you are getting accessing a name, you cannot also modify that value while you are accessing, or anyway modifying the value without notifying the engine that you did that modification. Otherwise, all the indexes of Drools will not work. This is another quite common, very common anti-pattern that I saw from time to time. I don't know why people do this, or probably people do this when they automatically generate rules, maybe because writing rules in this way is easier to be made programmatically than this. But in reality, what I'm speaking about is that we have this eval constraint that I regret having it. You really don't need it. You never need to use it. Please don't. We are keeping it only for backward compatibility reason in reality, but don't use it.
Let's put it. So it's there, but don't use it. That's it.
Don't
right?
use it.
Okay.
Easy. Don't use it. Okay.
Okay.
Why don't use it? So if you read these two things, I'm doing the same thing here and here. Okay. So what does this eval? Eval just takes a Boolean expression. Of course, you can use and there and or in this Boolean expression. So it evaluates a Boolean expression and makes the rule to activate, to propagate only if this Boolean expression evaluates to true. So if you read these two things, I'm doing exactly the same thing. I'm taking a person and an address from the working memory, and here I'm evaluating the constraint in this right normal way, and here I'm evaluating all. I'm just taking the person and the address and evaluating all the constraint in this eval node. Okay, what's the effect of this? The effect of this is that the person and address goes through the object type node, and then in this case, of course, I have the alpha node evaluating the name, so doing some filtering here. This other alpha node evaluating the street name for the address, so doing some other filtering here. So the set of join node of joined effect, joined tuple created at this point is quite low, and then you just have to evaluate one single constraint on this, and then you have the activation. What happens in this case? You have the object type node and for person and address without any constraints, so there is no alpha filtering, meaning that you have a complete Cartesian product. In this node, you have a complete Cartesian product of all the person with all the addresses inside your working memory. Okay, so and this could be enormous, of course. And then on each and every instance of this Cartesian product, you have to evaluate all the constraint with this eval node. And then of course, you don't have any indexes, and you don't have property reactivity. You don't have any. You are not using the rule engine at all. Okay, you are just using the rule engine to create Cartesian product and evaluate constraint on the resulting tuples of this Cartesian product. Of course, this kills performances, so please don't do this. Karina, let me know if there are questions about this. Okay, yeah, I have some written explanation of what I've said or what I just said, but I think I hope this should be clear.
Perfect. And we'll share the slides links for you who are watching and want to review this later. We do have a question here. So about another usage of the rules. So okay. Praveen said that sometimes he's seen people using the if-else clause, like the if-else under the then clause on the right side of the rule. I feel like that could be an anti-pattern. So what are your thoughts on this?
Yeah, I agree on this. Using if else in the right hand side, it is an anti-pattern because again you are not using the rule engine feature. So all the constraint, all the evaluation should be made at the left hand side evaluation level. I know that people sometimes do this to avoid duplicating rules. So you have the same set of condition except one, and then you write that one in the consequence. Okay, but you don't have to do this. Let me jump to reply to this question. Let me jump to this hint about using named consequence. Okay, so with named consequence, look at what I'm doing. I don't know if I have an example. No. Look at what I'm doing here. I'm saying if there is a customer that is older than 60, then I give him a discount. And if this customer is also owner of a car, I give him free parking. Okay, and I have to write this in two rules. But you can combine the two and have a dynamic consequence. So what I'm saying here is exactly the same thing. So it means that when the evaluation arrives here, execute this consequence labeled with this give discount. And then when it reaches the end, you can use this other consequence. I don't have a slide for this, but you can also put an if condition here. So say if there is a certain condition, do this thing or not do this thing. And in this case, other than this do keyword, you can also use a break keyword, meaning that with the do keyword, you execute this consequence and then continue with the evaluation. With the break keyword, you execute the consequence, but if a certain condition is verified, you have this break, meaning that the other pattern matching in the same rules are not evaluated anymore. Okay, so you can combine multiple rules, which is the reason why probably you use the if in the consequence. You can combine multiple rules with this by using named consequences. Okay, so I hope this replies to your question. Yeah, a few other hint about efficient rule evaluation. This is something quite obvious if you think about it, but not many put this in practice. Here I'm joining another line of flight. Probably this is a travel agency. I'm joining another line of flight, but the idea is that you always put at the beginning of the pattern matching the most restrictive pattern. So you have a much more aggressive filter in the early stage of the rule, and this prevents a lot of evaluation in the bottom part of the rule. In reality, as I said, Phreak is a bit more forgiving than Drools. So in reality, with Phreak, this is a little less necessary, but still one single object could activate a Phreak segment and create a lot of unnecessary joining and the rule evaluation if you don't follow this suggestion. Okay, this is another quite common anti-pattern. I see many people using this from statement. I don't want to say not to use it, but use it only when it's really necessary. So with eval, you don't use it full stop. I'm not saying don't use this from statement, but use it only when it's really necessary. These rules, two rules again, are doing the same thing, but one is materializing in the working memory all the employees for the company, and the other is using a proper join condition. So favor this second form if your domain model allows you to do so. Okay, this is something that I see also quite frequently. People want to figure out when a condition is fired and with which value it is fired. And then they start polluting the rule base with a lot of system out in the consequences. You don't need to do this. You can use listener. So you can have listener, for instance, when an object is deleted, then you can have a specific listener for it, or you can have a specific listener when a match is found for a specific rule and be notified by this listener when an activation for this rule is added to the agenda. So, or when it is fired, I don't know, in this case, it's when it's fired. There is also another listener when it's added, is just the activation is just created. So don't pollute your rule basis with those system outs. You can do much better with listener that you can, activate and deactivate very easily instead of adding system out inside your rules and then having to remove it and then you forgot it. You know what happens. Okay. I already commented this and I think I'm done. Are there any other questions?
Not so far. We're good to. Oh, you went through all the tips?
No. I'm done with my presentation. I wanted to know if there is any question about.
Oh, Mario. Good. Oh, right. Very nice presentation. I'm happy that we
Thanks.
were here to see it and hear directly from you about how it all works and the differences in between Rete and Phreak, and also some best practices based on this knowledge that we acquired.
Yeah, it was fantastic. Thank you very much for this first live session of the year, Mario. The content was like amazing, I think, and to be very helpful for our audience and for the posterity. That's the content that's always being available for we get back and check the journals of this deep dive. Has been a while that I don't see a material like that in the Drools environment. So that's amazing. Thank you very much for that.
So,
yeah, I know it was a bit low level detail, but
that's what we needed. That's exactly what we needed. So, Mario, any specific advice to work with date and time on Drools? Because we see that Drools already support Java 8 date and time.
Yeah, I don't have any specific suggestion. It's a fully supported data type for Drools. The only suggestion is that again, you don't have to do stuff like this. Am I still sharing? Yeah, you don't do stuff like this. That's the only suggestion, because you are comparing every time a new date is created here, it is created with the current timestamp, so that value is not stable. And again, this will break our indexes. So other than avoid this situation, I don't have any other suggestion.
Perfect. And we'd like to hear from you a little bit about what's going on for the Cogito rule engine.
So, as I anticipated, Cogito is our new project. it's basically Drools. I mean, of course, we are not rewriting the core engine, but we want to have. We want to bring Drools into the cloud together with our entire business automation suite. So together with JBPM and Octaplanner, we want to bring the whole business automation suite into the cloud. So Cogito is the effort for doing this. As I said, I must admit I don't know much about operators and Kubernetes and stuff like this. I'm learning, really. But again, my main idea, at least for this first stage, was to enable the usage pattern of having a function as a service evaluated with a rule engine. So a rule engine as a service. And as I discussed while speaking about the executable model, this is something we already achieved. So this is something already available with Cogito 1.0 that is out since the end of last year. Please give it a try and provide feedback. Thanks.
And as mentioned in the comments, I think later on we may have a session just for that.
Okay.
Just a cloud native rule engine, Cogito in here.
And just to wrap up, one last question. Do you know of any competitor for rules, like any other rules engine that does the same thing?
I don't know if you are speaking about this serverless thing. I don't know of any rule engine that can be natively compiled with GraalVM. And again, this is really a prerequisite for a serverless environment, because you cannot wait even 1 second to start a serverless node. You want it started in less than 10 milliseconds or 5 milliseconds, and really there are 2 or 3 orders of magnitude of difference. So there's no story about this. Yes, yeah.
Perfect. So Mario, thank you a lot for being here with us today. We really loved it, and we hope that we can join us again in the future. Okay.
Yeah.
Okay. Thanks a lot for having me.
Have a great day, Mario. Bye-bye.
Have your vaccine and your 5G chip as soon as possible. Okay.
Nice. Thank you.
Guys.
Bye-bye.
Bye.
Porcelli, looking forward for the next section. What? Porcelli froze. Okay, you're back.
No, I'm still here.
Yeah, you're here. So thank you everyone who's watching us today. See you next Tuesday, where we will talk about shadow variables on VRP and task assignment with Octaplanner with Geoffrey Desmet.
Yeah, and that's going to be another deep dive session.
Another deep dive session, exactly. So let's go for it. Have a great day, everyone, and bye-bye.
Bye-bye.